Hey guys, welcome back to Computational Biology with Python. In this video, we're going to be working on local sequence alignment. So aligning two sequences of DNA to determine how closely related they are. So let's just jump right on in. All right, let's save this as, call this one, what are we gonna call this one? Let's call this pairwise alignments. Okay. So first thing, let's just look at the aligner. Okay, let's first actually import what we need to do. From bio, import align. That would probably help. So we'll print aligner in a second. So let's open call our aligner up from the align package pairwise aligner. And we'll say, we can change the match score. So you can kind of tailor, there's default settings that most of the time you'll use. But you can tailor match scores and things like that depending on your system, depending on your DNA, etc. You'd have to, it's a case-by-case basis, so you'd have to like look in the literature for whatever you're working with. Oops, nope. So, no, actually, that's just doing the same thing, sorry. All right, so let's create our target sequence. So we'll say target equals GAACT. And so that's what we're aligning to. And then our query, or what we're interested in, equals GAT. These are tiny sequences to be comparing, but we're just doing this as an example. So we'll say score is a aligner score in our target versus our query. And then we can print our score. That probably should be spelled correctly, score, and then print our score, and you see we have 3 alignments, or a score of 3, because we have 3 overlaps. We'll print it here in a second. So let's do this, and then for alignment in alignments, I'll do a loop here, print alignment. And so as you can see here, we have the possibility of aligning our GAT like this, where we have the first 2 and then we have some gaps and then we have T, or we can do G skip A skip T. And so when you do these alignments, there's a lot of theory behind it. We might actually do some Smith-Waterman or really like a deep dive into how some of these alignments work. I'm undecided right now. What you can set up the scoring where you say, okay, a match is worth 1 point, a mismatch is worth -1 point, a gap is worth -0.5 points, or etc., to find the best possible alignment for your purpose. And so here we don't have any gap penalties. We just have a match score of 1. So you get plus 1 point, so to speak, every time there's a match. And then a mismatch or a gap is worth nothing. So that's where we get our score of 3. So let's do aligner mode equals local. And then our target, AGAACTC. And then our query equals GAACT. Our score equals aligner score target query. So we're just going to run the same thing, but with just a different sequence here. And then if we run score, we should see that we have a score of 5. Perfect. So our alignments equals aligner.align target query. And then for alignment in alignments, print alignments. Print alignment, not alignments. So here you can see that we have a score of 5. So it ignores the first 2 sequences, right? Or first and last nucleotide, but our GAACT maps to a GAACT right in the middle. And so you can count these number of lines in between, and you see you have 5, so that's where you get our score of 5, since we set our scores to 1 point each. Okay, so now let's do this print aligner. And you can see these are all the scores, right? So our match score, you get 1 point. A mismatch, you get 0. An internal open gap, you get 0. If you have a gap and you extend it, so you already got whatever points for the first gap, and then for each time you extend that gap, you can have a certain score. Left open gap, score. Left extend gap, so parts to the left, right. You can set all these scores to make to tailor to your organism, right? So like if your organism or your DNA sequence has a propensity for indels or transposable elements or something like that may have messed up, then you can tailor this, messed up the sequence. You can tailor your sequence or your mismatch scores for your alignment. So let's look at the algorithm. So this, how about we have a G in it? Algorithm. So you see that we're using Swift-Waterman. There's also, was it Needleman-Klein? I think is the other one. That are the 2 like most famous or most used. There might be something new out there. I don't align a ton of sequences. I have before, but not recently. Okay. You can also set like a significance, so we can do aligner epsilon. And so you can see it's 10 to the negative 6. So these 2 scores will be considered equal for each other for the purposes of alignment if the absolute difference between them is less than epsilon. So it's just a significant score, so to speak. Okay, so from bio import align, which we've already done, but we're doing another section here. Align pairwise aligner. Target equals GAACT. We'll put it back to our original target. And then our query equals GAT. Alignments equals aligner align target query. And then alignment equals alignments 0 alignment. So you can see we have this alignment object where there's 2 rows and 5 columns. Now alignment score. So what? So what we're doing is, we're looking at alignment objects. So it's kind of like seek objects where we kind of store all this information in a single variable beyond our just the actual sequence. So you can see that we can look at like positions of the aligner. We can look at the alignment score for this object. We can pull out what the target was for this object. So this was our target. We can pull out the query for this object, which was what we searched against our target, which was GAT. We can print the alignment like we had done above, so you can actually see the alignment. We can get the coordinates. So as you can see for this, we have, let's see how, so 0, 2 aligns to 0, 2, 2, 4 aligns to a gap, since 2, 2 is an empty string, so that would be here, was an empty string. 4, 5 aligns to 2, 3. So we have 4, 5 aligned to 2, 3, and 0, 2 aligned to 0, 2. So 1, 2, 3. Let's see. How does this work? Target 4, 5. Oh, 0, 1, 2, 3, 4. There we go. Aligned to target 2, 3. 1, 2, 3. So 5 aligned to 3, 2 aligned to 2, etc. We can look at the length of the alignment. You probably won't use the coordinates too much because you can. This is more intuitive just to look at it. So the length of the alignment is 2. We can look at the shape of the alignment. So it is 2 rows, 5 columns. We can look at the mode of the alignment, or we can set the mode of the alignment. So we can set it to a local instead of a global alignment. Local alignments equals align align TGAACT by GAC. And now if we look at local alignment equals local alignments 0. Now we can print our local alignment. And we see we have this GAC. Oh wait, why is Oh, so it just drops off the 2 end letters here, right? Because since it's a local alignment, it doesn't include everything like a global alignment would. And where am I at? So we can look at the shape for this one, which we see is 2 rows by 4 columns. We can do what else can we do? We can let's change it back. Okay, let's now look at global. So aligner dot mode equals global. Now we're going to say aligner equals pairwise. What was it? Pairwise look back over pairwise aligner. And we're going to say match equals 1.0. And we're going to say mismatch score equals -10. Was it pairwise aligner? This is what it should be. How did I type it? Oh, align.pairwise aligner. Okay, so now if we print aligner, you can see we've changed our mismatch score to -10. So let's do alignments equals aligner align AAA CAAA AAA GAAA. What's the length of our alignments? Got a length of 2. So print alignments 0, so our first alignment. And you can see that here we have an introduced gap, right? So if you think of the score, our score, we have 0. Where did that go? Oh, here we go. So internal open gap score of 0, an extended gap score of 0. So because of that score, it would rather put gaps in than have a mismatch, right? So if you look at our positive score, we got 6 positive, right? And then 2 0 points. As opposed to if we would pair these, the C and the G up, we'd have 6 positive and then -10. So we'd have a score of -4, which is a worse alignment in our set parameters. We can do print alignments 1, so our second alignment that was stored, and you can see it's the same thing, but just the G and the C are reversed. So let's do print local alignment. So this was our previous local alignment. And we can sort our alignments. So print local alignment. Oh, no, sorry. Local alignment dot sort. Let's do an underscore instead of that. And then we can print local alignment. So you can see it so how does this change that? Okay, I think that's a good stopping point. We still have some more alignment stuff to do, and this video is getting a bit long, I think. I'm going to have to make edits, so we'll see what it gets chopped down to. So that's a little bit about pairwise alignment. We'll continue on with some pairwise alignment in the next video, and then we will move on to another topic after that. So thanks for watching. I hope you enjoyed. Please hit like, please hit subscribe, and I will catch you in the next video.